Okay, ladies and gentlemen, here's the PowerPoint that I promised you, dealing with addition and subtraction with polynomials. Alright, so just like atoms are the basic building blocks of the universe, this expression called the monomial is the basic building block of polynomials. And it says that a monomial in X is an expression of the form k times x raised to the n power, where n is a whole number for your exponent right here. Okay? And k is any real number, and so it can be either positive or negative, but it acts right here as the coefficient of the variable raised to whatever power it is. Now, this n value is called the degree. And so whatever it is, let's say we've got 4x to the 7th power. Alright? Well, our exponent here is 7. And so this monomial would be raised to the 7th degree. And if it was 5, it would be the 5th degree. If it was 25, it would be the 25th degree. And so we look for the exponent right there, and that tells us the degree. Now, k is the coefficient. And we've dealt with coefficients before, because basically we'll take some coefficient, and that means multiply that coefficient by the variable. And so that's what a monomial looks like right there. Now, we get to the point that we're talking about polynomials. A poly means more than one or many. And so a polynomial is a monomial, or the algebraic sum or difference of monomials. And look at the S here, plural. So, like I said, monomials are the building blocks of polynomials. And so a monomial can be considered a polynomial, or where we add or subtract a bunch of them. Those are considered to be polynomials. We take all these different little monomials and we do what we got to do with them, and then we wind up with a polynomial expression. Now, like we said, the degree of the polynomial is the largest of the degrees of its terms after like terms have been combined. So once we combine all of our terms to try to simplify the algebraic expression, let's say we've got 4x to the 3rd plus 3x to the 5th plus 2, something like that. Well, what we want to look at is to express our terms in a way that we put the highest degree of the exponential values first. And so since x to the 5th is the highest one, I would put 3x to the 5th plus, and then the next one would be at 4x to the 3rd. And then lastly, 2 does not have an exponent, so it would go as the final element, or final monomial expression in this little polynomial. See how we have our exponents going from higher to lower. Now, the coefficient of the term with the largest degree is called the leading coefficient, and so since x to the 5th is my biggest exponential value, it is the highest degree or largest degree, and the 3 here is the leading coefficient. So I would have a 5th degree polynomial, and my leading coefficient would be 3. And that's how we can kind of define these polynomials. So let's take a look at the different kinds of polynomials that we can have. We obviously talked about monomials. It's basically a polynomial with one term. And here's a good example of one, 15x cubed. Here we have x raised to the 3rd power, so it would be considered a 3rd degree monomial because there's only one term. Now, binomial, bi means 2, so it would be logical to assume that we're going to now have 2 monomials, and it has 2 terms. And so now, look at what we got. (4x minus 10). Here's one monomial, here's the other one. And notice how x is raised to the 1st power. And so it would be a 1st degree binomial, and of course 4 would be our leading coefficient because it is associated with the largest exponential value in our little binomial. And if we can have binomials, we can sure have trinomials. Tri means 3. And so, obviously, a polynomial with 3 terms. Here's one right here. See the 3 terms, the 3 little monomials. Now, see here we got x to the 4th and x to the 1st right here. And so, since my exponent raised to the 4th power is the largest one right here, this would be a 4th degree trinomial because there's 3 monomials there. And then my leading coefficient right here would be a -1 because I have this negative here in front of x, and that's the same as -1 times x to the 4th right there. And so my leading coefficient here would be a -1. So let's try a few of these problems here and see what happens. Alright, I've got x cubed minus 2x plus 1 plus 3x squared plus 4x plus 5. And so what I'm going to do is to find values that I can combine. Well, looking at my exponents here, the highest value is x to the 3rd, and I don't see any other values or variables that have x to the 3rd, so I'll just have to write it down here by itself. And so I'm going to kind of scratch that one out. Now looking across here, I've got x squared, I've got x to the 1st right here, and so I don't see any other terms with x squared, so I'll bring it down. And it's a positive 3x squared, so I will write it as I see it. So I'm going to scratch that one out and get rid of it. Now, I've got a -2x to the 1st and 4x to the 1st. So I can kind of combine those terms. And so when I add those two together, -2x plus 4x is a positive 2x. So I will put that difference right here and scratch them out. And finally, all I'm left with now is my whole numbers, 1 plus 5. And so that gives me a positive 6. So what I have here now is a polynomial. One thing I did not mention that I'm going to go ahead and mention now is that, remember, we had monomials, binomials, and trinomials. Well, if we have 4 terms, what is that? Or 5 or 7, whatever. Well, any number of monomials above 4, we call it a polynomial. And so this would be a polynomial. My degree would be, looking at my largest exponent, would be 3, so it would be a 3rd degree. And my leading coefficient would be 1, because I have x to the 3rd, and there would be like an invisible 1 right here. And so that would be my my answer right here. X cubed plus 3x squared plus 2x plus 6. And so now let me see if I can erase this right here. There we go. Thought I had it. Let's try that again. There we go. There it goes. Took a little while to get it. Alright, so the solution is they removed all of the parentheses here, and then started combining terms. Got these 2 right here, and then these 2 right here. And then finally, final answer, x cubed plus 3x squared plus 2x plus 6, just like we did. And so there's your problem there. So now let's take a look at this one. We got 2x squared plus 4x minus 7 plus x squared plus 6x plus 8. And so looking at the exponents, I got 2, I got 1, I got none, I got 2, I got 1, and I got none. And so the highest exponential value here is 2x squared and x squared. And so I will combine those 2 together. So 2x squared plus x squared. 2x plus x would give me 3x squared. So I'm going to write that here to the side. So 3x squared. So I'm going to scratch those out. And so now I got 4x plus 6x. Well, 4x plus 6x gives me 10x. So I will add 10x to this and scratch those out. And so now I have negative 7, my whole number, plus 8. So negative 7 plus 8 gives me a positive 1. And so now I write down 1. And so what I've got here is a trinomial. My degree is second. Second degree, and I have a leading coefficient of 3, because my 3 is associated with the highest exponential value in my trinomial. And so there's the answer for this one. 3x squared plus 10x plus 1. Okay. So here's a solution just like we did it just like them. And there we go. 3x squared plus 10x plus 1. Yep, if I can get it erased here. Oh well, we'll just go on to the next one. Alright, now we're going to look at adding polynomials in a vertical format. You know how we can kind of take numbers here and add them together, like 2 plus 3 will give me 5. But I can also write it 2 plus 3, 1 over each other gives me 5 in a vertical format. And so that's what we're going to do here. So I'm going to write 5x cubed minus 9x squared minus 10x plus 12. And so once I've got that done, I'm going to go ahead now and write the lower term here. So I'm going to come down here. Then I have 3x cubed plus 6x squared minus 7. And I'll draw a line right here. Now notice, I've got 1, 2, 3, 4 terms up here in the top, 1, 2, 3 terms down here in the bottom. So I'm missing a term. I'm kind of in a bind right now. What am I going to do? So I've got to basically give myself a placeholder here down at the bottom so I can have 4 terms, so I can keep everything in a nice vertical format. And so I'm going to go ahead and rewrite 5x cubed minus 9x squared minus 10x plus 12. Now I've got 3x cubed minus 6x squared, but now for my x value that I don't have right here, I'm going to add a 0. Call it 0x as a placeholder. And so now I'll just move the 7 over one space and put it under the whole number, 12. And so now I can go ahead and add normally. And so 5x cubed plus 3x cubed is 8x cubed. A negative, and this is of course plus 6x squared. Negative 9x squared plus 6x squared would give me a negative 3x squared. A negative 10x plus 0x is of course a negative 10x. Then positive 12 plus a negative 7 would be a positive 5. And so here is my polynomial, because it has 4 elements, 4 monomials, so it would be a polynomial. My degree would be 3rd degree, because x to the 3rd is my highest exponential value, so it's a 3rd degree. And my leading coefficient would be 8, because it is with the variable with the highest exponential value. And so that's what I've got right there. Now if I can get this erased. try that again. Oops, that's not what I wanted. At least that function works. Let's try this again. There we go. So let me erase everything. There we go. And so, notice that x, or 0x is the written placeholder right there. And there is the math right here. Just what we did a moment ago. Now, if we can add terms, we can sure subtract. So how do we subtract polynomials? Well, very simple. We basically combine like terms. And so we got x squared y plus 3y minus 4x minus 2x squared minus 2x squared y minus 7x. Now, I'm not going to kind of highlight this right here because they show you two ways. And I want to go ahead and go over them with you. First thing we can do is to add the opposites of all the terms being subtracted. So from this point right here, where the minus sign is, we can change all of the signs from here on out by adding the opposites of those signs. So you see what we start off with right here with? This minus 2x squared y minus 7x. And so what happens, this negative becomes a positive. I put a negative in front of the 2x squared y, and I change the negative 7x to a positive 7x. And that's what happens right here. Alright? And so now I can combine terms. X squared y minus 2x squared y would be a negative x squared y. Now, there's nothing to combine with the 3y, so I'll just add it as is. Now, a negative 4x plus 7x would give me a positive 3x. And there's your answer right there, just like what I just wrote. There you go. Now, the next thing you can do is just multiply each term being subtracted by a negative 1. So here's our problem, and we're taking this second set of terms in parentheses and subtracting it from the first. Now remember, like right here I have a negative. That's the same thing as a negative 1 times everything in parentheses. And so what I can do is to distribute the negative 1 across the parentheses. And that's what they do here. And so negative 1 times 2x squared y would be a negative 2x squared y. Alright? And then negative 1 times a negative 7 would give me a positive 7x. And so now I can combine terms just like we did before and then come out with the same answer. And so I like to do the first step. I think it's so much easier just to change all the signs that are being subtracted. And like that, you're done. And I'm going to go ahead and demonstrate that on all the problems that we're going to be doing following this. And so let's take a look at this one. I got x squared plus 12x minus 23 minus 2x squared plus 7x minus 20. And so this is what's being subtracted. I'm going to change the signs right off the bat right here. So this becomes a negative, this is a negative, this becomes a positive. And so what I'm left with is x squared plus 12x minus 23 plus a negative 2x squared minus 7x plus 20. And so I find my terms here that are alike. I got x squared here, I got a negative 2x squared there, so x squared plus a negative 2x squared is a negative x squared. So I'm going to kind of write that down here. So a negative x squared, and I'm going to get rid of these, scratch them out so I don't count them again. And so now I see my x's here. I got 12x minus 7x. That works out to be 4x. So that would be a positive 4x. So this will cancel. I'll get rid of that. So now I have a negative 23 plus 20. Negative 23 plus 20 is a negative 3. And so my final answer is a negative x squared plus 4x minus 3. Final answer. So if I can erase all of this. Alright, there we go. So, change the sign of each term in the polynomial being subtracted and combine like terms. So we change the signs, like we got right here, and then combine. Negative x squared plus 5x minus 3. Now, if we can add vertically, we can also subtract vertically. And so all we do is just change the terms of the polynomial being subtracted and then combine all the terms. So here's the one we just did. See how we have a negative x squared plus 12x minus 23 minus 2x squared plus 7x minus 20. And so all I do is I just change the signs of everything being subtracted, just like they did right here. And then we combine terms and just subtract vertically. I like this method right here because it helps to keep you really organized. Alright, so let's take a look at this one. I got 6x to the fourth, 2x plus 2x cubed minus 4x squared minus 8. So I'm going to go ahead and write it down here. So 6x to the fourth plus 2x cubed minus 4x squared minus 8. And so now that's minus 3x to the fourth plus 5x cubed minus x squared. Whoop. See, I've got 6x right here. I don't have an x up here. And so I've got myself an issue right off the bat. So I need to come back and put myself a place value up here at the top. And so let me get that done. Here we go. Alright, so I got 6x to the fourth plus 2x cubed minus 4x squared. And so now I want to put this x here, or place value for my x to the first value. So I'll add a 0x here, and then negative 8. And so now I have 5 terms, and so I'll subtract 3x to the fourth plus 5x to the third minus x squared plus 6x plus 10. Now, I'm going to change all the signs now, and let me go ahead and see if I can change colors here. There we go. I think I'm finally getting the hang of this. I'm going to go with this purple right here. Alright, so now to change all the signs here of the bottom polynomial, my minus becomes a plus, 3x to the fourth becomes a negative 3x to the fourth, my positive 5x to the third becomes a negative 5x to the third, my x squared, negative x squared, becomes a positive x squared. My positive 6x now becomes a negative 6x. And now my positive 10 becomes a negative 10. And so now I can combine terms. So 6x to the fourth minus 3x to the fourth is 3x to the fourth. A positive 2x to the third minus 5x to the third would be a negative 3x to the third. A negative 4x squared plus x squared would be another negative 3x squared. And of course, 0x minus 6x would be a negative 6x. And negative 8 plus a negative 10 would be a negative 18. And so there's your polynomial. Now we have 1, 2, 3, 4, 5 monomials, so this would be a polynomial. The highest degree would be a fourth degree, and it would be a, what's my leading coefficient? Would be 3. Since it's associated with the largest exponential value. And so there's my answer right there. Oops. Not what I wanted to do. And so there they put in the place value here, and then line up everything vertically and do the math. So to kind of wrap things up here, the last thing is to evaluate polynomials. It says for the polynomial p of x is equal to x cubed minus 2x squared plus 3x plus 5. Find p of 4. And so all you're going to do is take p of 4, substitute 4 for all of your x values, here, here, and here. So this would be 4 cubed minus 2 times 4 squared plus 3 times 4 plus 5. Now notice how I'm kind of put my 4's in parentheses here. That helps me to kind of keep them separated since I'm plugging 4 in right here. And so 4 cubed, 4 times 4 times 4 is 64. Now, remember with our order of operations, we look at exponential values first. So 4 squared is 16 times a negative 2 would be a negative 32. And so this would be a negative 32. So 3 times 4, positive 12, plus 5, bringing up the rear. Now remember, with our order of operations, we have subtraction and addition that are at the lowest level, and we just work from left to right. So 64 minus 32 would be 32. Then I add 12, which would be 2 and 2 is 4. 3 and 1 is 4. So that would be 44. 44 plus 5 would give me a total of 49. So P of 4 is equal to 49. Final answer. And so, substitute 4 for x throughout the polynomial. P of 4, and there it is right there. And then they squared, cubed, combined all the terms, and did the addition. So P of 4 is 49, just like we found it to be. Now here's one more where we have two variables, x and y, kind of like an ordered pair right here. And they want us to find x equals -1, y equals -6. And so P of -1, -6 would be equal to 2 times a -1 squared times -6 minus -1 times -6 plus 3 times -1 minus 4 times -6 plus 15. And so doing my exponents here, my order of operations with my exponents, so -1 squared, -1 times -1 is a +1. So what I got is 2 times +1 times a -6. So 2 times 1 is 2 times -6 is equal to a -12. So that would be a -12 right here. I'll kind of write that right there. Now, you see how I have -1 times -6? And so -1 times -6 is a +6. But see how I have that negative here? I don't get rid of it, so that becomes a -6, or 12 minus 6. Now 3 times -1 is a -3. A -4 times a -6 is a +24. And then I bring my 15 down like so. And so now, working from left to right, -12 minus 6 is a -18. -18 minus 3 is actually a -21. -21 plus 24 is a +3. And 3 plus 15 yields an answer of 18. And so P of 1, a -1, -6 is equal to 18. Final answer. All you do is plug in your values for x or y or whatever your variables are, and you solve the equation. That's all you got to do. These are some of the simplest problems that you'll get in this chapter. Substitute -1 for x, -6 for y throughout the polynomial. Do the math, combine terms, add them up, 18. So, that wraps up our little discussion here on 4.2. I wish I could have been there to do it live, but hopefully this will get you through the lesson whenever we get back Thursday, weather permitting, or else hopefully if you know, we're not all flooded in. I'll answer any questions that you have on the video, and so look forward to seeing you then. I'm going to go ahead and stop the video at this point.